Okay, guys, here we go. Today we're learning more log functions, and we are going to solve some exponential equations using logs. So the do now is kind of basic, and we haven't really talked about this yet, but if you notice in the do now, you are looking at the same base, okay? You have a base of 5 and you have a base of 5 on both sides. And when you have the same base, so I'm going to just make a little note, okay? When you have the same base, you are allowed to drop the base, okay, and then you are just going to set your exponents equal to each other. So here we would take 3x plus 1, set it equal to 2x. I feel like I want to subtract the 2x, and then I'm going to move the 1 over to the other side, and I wind up with x, that's 0, is negative 1. That's it. You're setting, and then you're solving. Okay? So in your next question, when they're saying solve for x to the nearest thousandth, you know you're getting a decimal, and you know it's got to be less than 1, because 5 to the first power would equal 5. So what we can do is take our exponential form and turn it into log form. And remember that a log is an exponent and bases never change. So this would be log base 5 of 3 equals x. And you could take this entire piece, log base 5 of 3, and put it straight into the calculator. When you do that, solving to the nearest thousandth, you should have 0.683. There's your x value. As easy as that. In your next example, they're just asking you to state and show how the statements are true. So you could really put both sides into the calculator, and you'll see one side equals the other side. The other thing we could do is just do a little simplifying, like here, 8 to the third can be simplified. I could say log base 2, 8 to the third power is 512. And on this side, there's really nothing to simplify, but if I took this, log base 2 of 8, so let's talk about that. Log base 2 of 8. If I turn that back into exponential form, that really means 2 to what power gives me 8? And I know you'll all know that 2 to the third power will give me 8. So that's technically 3 times 3. And I could also take this side now that I simplified it, and if I turn that back to exponential, that means 2 to what power gives us 512. And it's actually 9. So if this side is 9, this side is 9. And again, that's your proof that one side equals the other side. Again, you could put them both in the calculator and you would see they would both equal 9. So what did I want you to see from that? That your exponents become your coefficients. If you see this exponent here is going to be equivalent to becoming your coefficient on the other side. Your exponents become coefficients. So let's try to solve a few things. Let's go to the next question. And it's a little interesting because you do see an exponential, but you do see a coefficient in front of your exponential. Does everybody see this 5 in front? So I'm going to put a little star and just make a note that you must divide both sides. I'm going to say, sorry, I messed that up. You must divide both sides by the coefficient before turning into log form. So if I divide both sides by 5, I have 10 to the y equals 240. Now if we turn this into log form, again, remember, a log is an exponent. Okay, so it equals the exponent, and bases never change. Okay, so think about this. Log base 10 of 240 equals your exponent of y. So now you can go right to your calculator and you could do log base 10 of 240. This said round to the nearest tenth. I think you get 2.3802. Again, go right to GeoGebra, and you would simplify that to 2.4 when you round to the nearest tenth. Okay, let's talk about this next one where you see an E. Remember that your base of E is your natural log. So your log base E, remember, is that natural log, okay? So when you see E to the 4x equals 12, let's turn that into the natural log. Your natural log, instead of log, you're going to use natural log, which is ln of 12 equals your exponent 4x. Okay? You don't need to write that little e as your base. It's like that little unknown thing, like a coefficient of 1. So now, if we want to solve for x, what do we need to get rid of? Divide both sides by 4. If you do that, you're going to go straight to your calculator and you are going to type in natural log of 12 divided by 4. Remember to use ln instead of log. And you see something like 0.6212. And if they wanted you to round to the nearest hundredth, 0.62 should be your answer. Okay. I'm going to let you guys try maybe the last two on your own, but I will post both answer keys, or would you like me to do it? Maybe I'll just work it with you. Okay, so a population of rabbits is doubling every 6 days. You see that formula. P equals 10 times 2 to the t over 60, where P is the population of rabbits on day t. What is the value of t when the population is now 320? So if you now know that P is 320, here's your equation. 320 is 10 times 2 to the t over 60. And remember, we want to solve for this t, and now we know log, so now we can solve for exponents. Remember, get rid of that coefficient. So I'm going to use a different color, and I am going to immediately show that we're going to divide both sides by 10 to get rid of that coefficient. So we have 32 equals 2 to the t divided by 60. Okay, so now let's talk about this. You have this exponent of t to the 60th. You don't want that, so we're going to rewrite this in log form. Remember that a log is an exponent and the bases don't change. So think about it. What's the base 2? Log base 2 of 32 equals that exponent t over 60. And now if we want to solve for t, get rid of that 60. So let's show to multiply both sides by 60. That's going to simplify this side. And now on this side, you're going to go into your calculator and you're going to do 60 times log base 2 of 32. That'll tell me what t equals. When you go into the calculator, you get 300 And here we're talking t was in days, so 300 days. Okay, here comes your last one. Important words. Sean invests $10,000 at an annual rate of 5% compounded. Here's the important word, continuously. Okay, that's immediately giving us and telling us we need to use our PERT formula. Determine how many years to the nearest year it's going to take for your initial investment to double. Okay, so let's talk about this formula. You know your initial investment, your principal is $10,000 times e to the rate of 5%, which will be 0.05 times t. They want to know when that is double. Well, if we initially put in 10,000, our double would be $20,000. And once again, we want to divide out that coefficient of $10,000. So now our equation is going to leave us with e to the 0.05t equals 2. And again, rewrite it with your natural log. The natural log of 2, we don't need the base is e, is equal to our exponent, 0.05t. Okay, and if we want to solve for t, I am going to divide both sides by 0.05. Go to your calculator, those will divide out, and you get your value of t. They want it to the nearest year. I think it comes out to 13.8629, which in years to the nearest year should be 14 years. Okay. I hope everybody's okay with that. I'm going to post a little homework assignment, but you could pause the video, go back, look through, email me, ask me any questions. One day at a time, guys. Okay. See you guys later.